What if rigid chips could live on rubbery bands without popping off? A new Nature Communications paper copies plant roots to make electronics that stretch like skin while the chips stay in place. Stretchable gadgets usually fail where a rigid part meets soft silicone. All the stress piles up at that border. Cracks start, lights go out. Serpentine traces and kirigami help, but the weak spot is still the interface. Plants anchor into soil with branching roots. The team laser cuts tiny roots into a thin, flexible island, polyimide, then embeds those roots inside Ecoflex, a soft silicone. Primary roots spread stress. Smaller secondary roots mechanically interlock, so cracks can't race along the border. Think Velcro-like gripping, without glue. They call it BIEFI. Computer simulations and slow-motion strain mapping show the rooty interface keeps crack tips closed. Without roots, failure starts around 80% stretch. With primary roots, stretchability jumps. Add secondary roots, and the platform reaches about 690% strain before the interface gives in. That's like pulling a 10-centimeter strap to 69 centimeters and still working. They mount LEDs and flexible solar cells on the islands and keep them lit while stretching, twisting, even poking. Tests meant to mimic real wear. A smart resistance band logs strain and motion over reps, BLE Arduinos on the islands, and a wrist pulse sensor reads a clean waveform at approximately 69 beats per minute on a moving arm. Translation: not just a lab coupon, actual modules survive real motion. Where would you put this first? Sports bands, soft VR gloves, or solar tapes for backpacks? Drop your pick, and I'll prototype a concept in a short.